Hi guys, Raz here to help you through your maths difficulties. So today I'm looking at iteration and the Newton-Raphson Method. This goes out to one of my listeners, Lil Dicky out there. Let's go. So let's start with iteration. Common questions I get. Why? What does it mean? Why does it work? Hopefully we'll be able to answer most of those questions in this video. So, typically with iteration, firstly you'll get given a function and you get asked to rearrange it to show that the equation can be written as something like this. This is what we call being taught how to suck eggs. Yes, if you're not sure what to do here, I'll say it slower and louder for you, as learned in teacher school. So what we have to do is make x equals. So first thing is, I let it equal 0 because it says the function is equal to 0 and my function is x squared minus 4x plus 1. Then I'm going to move the minus 4x and the 1. Then I need to divide by x here. Now I simplify that. What do I get? Loud, I can't hear you. Oh, small technical issue there. Louder. What do I get? That's right. I get 4 minus 1 over x. So apologies for the not so seamless transition there, but that's all you do. The hint is, it's a show that so you know what you're working towards. So that should be straightforward. That is within the topic of iteration. So typically these questions are exam questions paired together, iteration and Newton-Raphson. Now I'm asking you to find the root or show that there's a root between 3 and 4 for the same function. Now this is GCSE. Yeah, so what we do is we sub x3 in. If the root's between 3 and 4, we know that 3 isn't enough and 4 is too much. So if the root has to, if that function has to equal 0, not enough would mean that the answer is, yeah, exactly, negative. And if we put 4 in, what would the answer be? Shh. Not all at once, hands up. You over there. Exactly, too high. So that means if we put 3 in, it's too low. We put 4 in, it's too high. So on the sub 3 in, I get minus 2. On sub 4 in, I get 1. So the solution must be between 3 and 4. This is standard for iteration. Then this is the recurrence relation and using an iterative formula. So we've got part A and B done. So this is the final part. Now, remember, I always describe this as if xn is today, what is xn plus 1? That's right, tomorrow. And if xn plus 1 is today, what was xn? Yesterday. So I'm going to sub in, when n is 0, I'm going to get this value. Yeah, because 0 plus 1 gives us x1. So x1 is 4 minus 1 over x0, which gives us 3.67. And then I'm going to use the 3.67 to find x2. So x2 is 4 minus 1 over x1. If x1 is 3.6 recurring, that's what I'm going to type into the calculator, and that's the result I get. Then I do this again. That's the iteration part. It's just doing it again. So I sub in x2 is 3.72 recurring, and I end up with that as an answer. What is this value tending closer and closer to? Well, clearly 3.7, most likely 3.73. So the solution is converging towards 3.73. There's iteration. And iteration lets us solve an equation without solving it. So obviously it's introducing with very basic equations. But imagine a really complicated equation that's too difficult to solve. You're just going to start guessing. Well, to guess between two values, you need to have a technique, and our technique is that we'll get a sign change. That is it. That is iteration. Iteration is guessing a solution. So bearing that in mind, what is Newton-Raphson? Well, it's a better method. It's a better type of guessing. It's a better approximation than iteration. It involves some differentiation. And that is the formula for Newton-Raphson. So it's a better way to guess. So we've seen iteration in GCSE. Why couldn't we see Newton-Raphson in GCSE? Hands, please. You in the back corner. That's right. Because most of you couldn't differentiate at GCSE. What's the problem with Newton-Raphson method? Exactly. You need to differentiate. So I'm going straight into a question. So you can pause this and read the question. I'm just going to keep talking. So for part A, explain why x naught equals p is not suitable. Well, if we look at the Raphson formula, we need to put in the function and then divide it by the derivative. Yeah. But if we look at, and we sub in the value of x, if we look at the diagram, the value of p is at a stationary point. What is the gradient of a stationary point? Exactly, it's 0. So if I sub in 0 into a denominator of a fraction, what happens? Exactly, the answer is infinitely large. Maths error, it don't work. Man or like. Yeah, that's it. So that's the flaw. If someone says, what's the problem with Newton-Raphson method? You can't divide that quotient part by 0. Done. So you need to be careful what values you pick for x. You could have picked a little bit to the left of p or a little bit to the right of p, just not p. So that's part A in words. Now part B now says using x naught equals 2 as the first approximation, use the Newton-Raphson procedure twice. So that means if x naught, we have x naught, that means x1 is dependent on us having x naught. And x2 is us dependent on us having x1. So bearing that in mind, yeah, the function we're given is x cubed plus 2x squared minus 5x minus 4. We need the first derivative of that, which is 3x squared plus 4x minus 5. And we're given x naught is 2. So with that information, we can figure out what the value is when x is 2. So I figured those out there, yeah? So f2 would be 2 and f dashed of 2 is 15. The bit in red, I'll come back to in a minute. So I'm going to go into the question and answer it. So this is what we have so far. And to find x1, we need x0 minus the function when x is 2. And then we need the derivative when x is 2. Remember, x is 2 because we're given x0 is 2. If I sub that in, I get that, which gives me 1.86 recurring. What do I need to do with that? Exactly, that is 1.86 recurring is my x1. So I sub that into the formula. Sub that in, I get this. But x1 is 1.8 recurring. So the first part, when we sub that in, the final result gives us that x2 is 1.8558. So pause it here and just look at what I've done. All I've done, you can check these numbers on the calculator. So f dashed when I subbed in 1.86 gave me 12.91. And when x1 was 1.86 and I subbed it into f, when I subbed this in there, I got 0.13985 and so on. Just pause it and look through that. And that's the answer, yes? So a suitable value, so the question said to 3 decimal places. So fair solution would probably be 1.856. Well, it would be. So part C is by considering the signs change, show that your answer is accurate. So this is just iterations. This question in an A-level is now bringing it back to iteration. So we found X was 1.8558. Yeah, when we round that, that's 1.856. That means X must be between the upper and lower bound of 1.856, which would be 1.8565 and 1.8555. So I sub those in. When I sub those into the original function, I get a negative and a positive. The sign change has occurred. So therefore, 1.856 is a suitable solution. And that's it. That concludes Newton-Raphson.